Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about the Unicast routing algorithm. So Unicast means the transmission from a single sender to the single receiver. If we are communicating over the network, and in that there are only two hosts is available, only one is sender and second is a receiver. So that types of communication is called a unicast, because there is a one-to-one communication. So it is also called a point-to-point communication between sender to the receiver. We already learned what is a point-to-point communication. In the point-to-point communication, there is one sender and receiver, and they only communicate with each other directly. There is no other host is available in between them. So that is the unicast communication. And if we want to do these types of communication, then the algorithm used or the protocol used is a unicast routing protocol. So there are various unicast protocols such as TCP, HTTP, etc. So TCP is the most commonly used unicast protocol. It is a connection oriented protocol that rely on acknowledgements from receiver side. There are three major protocols for unicast routing. So if you want to communicate over the network and your communication is a unicast, and so for that mainly there are three routing algorithms. First is distance vector routing, second is a link state routing, and the third is a path vector routing. So in today's lecture we are just going to cover with this first algorithm, which is a distance vector routing. So let's start with this. So distance vector routing means, in distance vector routing, the least cost route between any two nodes is the route with the minimum distance. So suppose this is one host and this is a second host. Because this is a unicast communication, so there is only two hosts available, and in between there are multiple routers is available, because network is combination of multiple routers. So this 4 router is available in this network. So if this one wants to send message to this second host, so the route can be possible like this. This is a second path, and the third path can be, this is 1, 2, 3 and 4. So these are the multiple routes that is available if we want to send a packet on the network. So in the distance vector routing, the least cost route between any two nodes is the route with the minimum distance. So which is the best route, or which route is selected if you are using the distance vector routing? So the route which has a least cost. So suppose the cost between this route is 1, 1, 1, 1, 2, 1 and 1. Yes. So suppose this is router 1, this is second router, this is a third router, and this is a fourth router. Yes. So how we can calculate the distance between any two routers? Suppose the host 1 to router 1, and the router 1 to router 2, and the router 2 to host 2. This is a host 1. So this is the first path. Yes. So the distance between host 1 to router 1 is 1. This one distance between router 1 to 2 is also 1, and 2 to host 2 is also 1. So the cost is become 1 plus 1 plus 1 equals to 3. Now the second route is something like that: 1 and 3, 3 to 4 and 4 to 2. So also the distance is 1 plus 1 plus 1 equals to 3. So the distance of these two routes is equal. There is another route through which we can reach to the destination. So this is a from host 1 to router 1, then router 1 to router 1 to router 2, and router 2 to router 4, and router 4 to router 2. So if we choose this route, so the distance become 1 plus 1 plus 2 plus 1. So the distance become 5. So the minimum distance route is these two routes, host 1 to router 1, 2, and host 2, and host 1 to router 3, 4, and host 2. So these two routes are optimal. We can use any of the route between this two route. So this is how the distance vector routing is used. First, it calculates the distance between each route, and it selects that route which has a minimum distance. So in this protocol, as the name implies, each node maintains a vector of minimum distances to every node. So vector means a routing table. We already learned what is a routing table. It maintains the route information. So each and every node, here host 1 is also a node and router 1 is also a node. So each and every node maintain that routing table, maintain that vector table, and in that table the distance of each route is mentioned. So based on that distance, it can travel through the network. So the table at each node also guides the packet to the desired node by showing the next stop in the route. So this is the basic of distance vector routing. So this is suppose a network, and there is A, B, C, D, and E. These are the 5 nodes available in the network. So each node has their own vector. So this vector is called a route table. Each node has their own different route table. Yes. Now let's understand. This is a node A, and its routing table or the vector is this. So here the distance from node A to node A is 0. Distance from node A to B is 5. Distance from node A to C is 2. A from D is 3, and A from E. So there is no direct path. So 2 plus 4 is one path. So 2 plus 4 becomes 6, and the second route is 5 plus 3. So this is greater than this route. So the minimum distance is taken. So 4 plus 2 is equals to 6, and at the end next stop is C. So this is how each node has their own different vector table, in which the cost of each route is defined. So based on this cost, the packet choose their route. So if there is two table available, there are two routes available at the same node. So at that time it choose the route with the least cost. So a router using distance vector routing protocols also known two things, which first is distance to final destination, and a vector or direction traffic should be directed. So these are the information that is maintained. Next is the characteristics. So periodic updates, LF neighbors, broadcast updates, entire routing table is included with routing updates. So these are the characteristics of these algorithms. And the routing updates means when the routing table is updated. So routing table updates occur periodically or when the topology changes, because when topology is changed, the route is changed. Yes, so that is why the distance is updated. Directly connected networks are initially placed in a routing tables. Distance vector algorithms calls for each router to send its entire table to each of its adjacent neighbors. So each and every node has the information about their neighbor's route, so that can help to route the packets easily. Now let's understand how distance vector routing algorithm is used. So suppose this is a network that I already said to you. So now this is the initialization. If this is a one network, when it initialized, when it started, when we activate the network, at that time the vector is initialized, the routing table is initialized for each and every node. So at the first stage the distance is computed. Here the distance is infinite. Infinite means because from A to E there is no direct route available. Yes, so for that the distance we will write is infinite. So that is why here written is infinite. Here from B to D there is no direct route. No direct path is available. So that is why here distance is infinite. So that is how we can write the distance from each node to other node. So that is the first step of initialization. After initialization, packet starts traveling. If it go from node A to B, yes, so when it comes to B, then after the route table is updated, yes, based on the situation, based on the destination, the route table is updated. If it packet reaches to the B and topology change is detected, so at that time route table is also updated. So next is update table of node A. Suppose this is a table, and now based on this figure we can see that the distance of A to B is 5 and A to C is 2 and A to D is 3. So there are main 3 paths from A, so and the minimum distance is 2. So the packet choose this route from A to C. So that is why when the packet is received at C, so the table is of C vector. So at this situation the vector table or the routing table of C is written here. Now this based on this information, the node A's routing table is updated. Yes, after that the table it is compared between old and modified table, and based on that, so this is a modified table and this is a old table. So if there is a change in distance between old and modified packet, then the route is changed at the new A's table. So this is a new A's table in which here from if we want to distance between A to A is 4, here distance between A to A is 0. 0 is a list, so that is why it is taken. Same as all the distance is computed here. Distance between A to D is infinite, and here is distance between A to D is 3. So 3 is a list, so that is why it is chosen in the new A's table. So this is how the routing table is updated. It when it reaches to that particular node, then after the table is modified based on the current situation. After that, the second step, it compare the two tables. First it compare between old and modified tables, and it compares that in which table the distance is list, and based on that the new table is created, and now this new table is stored at the node A. So this is how all the nodes is updated when packet reaches to the another node. So that is all about the distance vector routing algorithm. Now advantages is simple to implement and maintenance, low resource requirement, less memory, and no need of powerful CPU, while the disadvantages are so slow convergence because at each node the table is updated, so it takes time, limited scalability and routing loops. So these are the disadvantages of distance vector routing algorithms. So that's it. Thank you so much for listening.